Righto, let's make a start.
It's like listening to hype. It's like listening to hype music and like that's the point.
Get myself.
Or you're always hype, so
Transformations using matrices.
oh
no. Oh, yes. All right. So the table below summarises.
It's not like I raise them from the finder.
Is that good working out here?
It's easy to take out.
Chocolate.
Get it? Because latte is it's amazing.
It's on the bottom. Chocolate.
Yes, it's a
All right. So we've got 3 columns here in this one. So we've got our transformation. Or the mapping. Right, so sometimes I'll say if something's mapped to, transform to. We've then got the rule as to what the change is, and then we've got the matrix. So for the first one, I'm going to do reflection. In x-axis. So when we reflect in the x-axis, what changes?
The Y value.
Y value. So our new Y value
That's negative.
is the negative of the old Y value. So when the matrix that does that for us is this one. 1, 0, 0, negative 1. Now each of these transformation matrices goes in the front of our x and y. So what are we doing to our originals? So what are we're doing this to our original to get our image. Alright, so this matrix times our original gives us our image. Alright, so that's reflection in the x-axis. Reflection in y-axis. What changes there?
The X value.
The x value becomes negative. The y stays as it is. So the matrix that reflects that is the negative 1 up here, 0, 0 and 1. This stuff in blue goes all the way down there. All right, some dilations. So the first one. Factor K from which axis first? From the y-axis. So if we go K from the y-axis, what changes? We're moving away from the y-axis, what changes?
X.
X. Alright, so x gets bigger, so our new x, our image, is k times the old x, and our y values stay the same. And the matrix that reflects that is the k up the top, is that particular matrix. Alright, so dilation factor k from x-axis now. What changes?
The Y.
The y. So our image of x is the same, but our image of y is now k times. So remember using that word factor, factor meaning multiply. Just factors multiply together, remember? Alright, so the matrix has the K down in that bottom corner there. Okay, so hopefully you notice a little bit of a pattern. Anything that's affecting the X, it's this number up here. So if the X doesn't change, it's a 1. If the X changes in some way, it's something else. And the Y, things that change the Y, they're the ones down here for these transformations. Alright, now there is another one that we haven't done a lot on, but we have, especially when we did inverse functions. Reflection in the line y equals x. So the question is, what changes? So there's a rough sketch down here. Here's the line y equals x. So say for example, I have a point here that's 2 and 1. When I reflect that point in y equals x, reflecting it over to here, what are the coordinates of that, of this point?
1,
1, 2. So what's effectively happened?
2. This one's.
The x and the y have swapped. So the new x is the old y, and the new y is the old x. So how can we represent that in a matrix? Well, we can represent it in this way. Oops. Alright, so just to show you, if I multiply our old 0 times x plus 1 times y, 1 times x plus 0 times y, so that matrix swaps them over. Alright, so there's all of those. Now I haven't done translations. Translations. So when we do translation, so all of these things have all been multiplied, but when we do translations, what do we need to do? We need to add. So translation in the X direction would be that our new one is the old one plus whatever our translation is. If we did it in the Y direction, it would be our old Y plus whatever our translation is. So in matrix form, we are adding a matrix. And when we're adding it after. So all these ones where we multiply, they always go in front. And then when we're adding, it goes behind. Alright, so there are our matrices. Let's do some examples. Got a few examples. Alright, we got that. Can rub off the left hand side, can I?
Sure.
Okay, so if we're going to use this simple one, so we can use this on a point. If we've got a point, we want to find the image. It's a simple one because there's only just one transformation. That's the dilation of 8. So our transformation matrix will reflect that. So for our transformation matrix, if it's from the y-axis, then the x changes, and because it's 8, factor of 8, it's there. Now, the point, we put the point in matrix form. So the point matrix would be the x goes at the top and the y at the bottom, so we end up with that. So to do this as a matrix, to find the images, we need to multiply those matrices together. So there's our matrix equation. So when we multiply matrices, what's our process that we use? Cross the row down the column.
Yeah.
Multiply the elements and add them together. So 2 8s are 16 plus 0 3s, which is 16. And then for the y, 0, 2s plus 1, 3. So our image, our new point, is 16 and 3. Okay. Yeah, it'd be nice if it was always that easy, and however, that's methods, so it's not. So let's look at this next example. Wrong way. All right, so here this trees transformation is a bit more complicated. Excuse me. We've got this point gets mapped to that, we've got this point gets mapped to there, and as you can see, the x value and the y value changes in both cases. So what we need, excuse me, what we need to do is find out the transformation matrix we need to find out what that is. So how do we do that? Well, we label our elements of our transformation matrix as A, B, C and D. Then we have these two transformations. So our original, our image. So we need to put our original point value, our image point value, and then see what we get. So for this first one, I've got A, B, C, D. It's our transformation matrix, and we're multiplying that by 1 and 0. And when we do that, we get 3 and minus 1. So when I multiply these two matrices together, what do I get? I get A times 1 plus B times 0, which is?
8 and 0.
Yep. And the next row, C times 1 plus D times 0 is just C. 3, negative 1. So from this, we can conclude that A has a value of 3, and C has a value of
-1.
-1. Alright, so that's one of our points, that's the first one. We've got another point, so let's do the same with that other point. But now we've got some information, so we can put that in, we can put the 3 in. B we still don't know. The C we know that's -1, and the D we don't know. So when we multiply that by this point, which is 0 and 1, we get our image, which is -2 and 4. Alright, multiply that out. 3 times 0 plus B times 1 is just B. -1 times 0 plus D times 1 is just D. And so from that we can conclude that B is -2 and D is 4. Alright, so it's quite a, when I put my transformation matrix together, this transformation's a little bit more complex than what we were looking at earlier. So we've got 3, -1, -2, 4. So it's just got all sorts of dilations and reflections and stuff going on in this one. So if I want to find the image of -3 and 5, what do I do with those two things? I times them. So if I multiply 3, -2, -1, 4 by the point that we've got, which is -3 and 5, then I will get my image. Alright. Let me write this out longhand, just to remind. So 3 times -3 is -9. 2 times -2 times 5 is -10. So we've got to subtract those. Then the next row and column, -1 times -3 is 3. 4 5s are 20. And when we put that together, we'll get -19 and 23. So our point then, because we're asked a point, so we need to put it back in coordinate form, is -19 and 23. Okay. Yep.
Just a question. With these questions, how are you supposed to know you're supposed to use the matrices?
How do you know? By the way the questions are worded. The way the questions are worded, they'll indicate that that's what they,
Yep.
what we want, or they want.
Okay.
All right. So composition of mappings. So if we've got more than one thing, so like that one we just did's got a whole bunch of stuff in it. But if we have got two transformation things, so if A and B are two transformation matrices, and we apply them in the order A, then B, so what we've got is we've got our normal x and our y, and our first transformation is to multiply it by A to get that transformation. Alright, so we multiply that out, and when we multiply that out, we'll get a single matrix, whoops. We'll get a single matrix, which is the product of those two. And then we multiply matrix B in front. Now, when I've done that, what do you notice here? The order here.
B and A.
B and A. So when it says we apply A first and then B, so the one that we apply first is closer to our original one, yeah? So if I wanted to make one single matrix out of A and B, this is the order that it would need to be in. It would need to be, so it's kind of flipped around if you like. So a single or composition matrix which is to represent the transformation is B times A. Alright. So we've done A first then B, but if we want to combine that and get a single, it needs to be BA. Alright. Because A's done first, it's closer to our point matrix. Alright, so let's look at an example of that specifically, but an example of a matrix. Actually, I will do an example of that. Alright, so A is our reflection. So it's a reflection in the x-axis, so reflect in the x-axis, the y changes to negative, so it's 1, 0, 0, negative 1. And matrix B is our dilation. And that's from the y-axis, so we move away from the y-axis, that changes to x. So that's 3, 0, 0, 1. So our composition of those would be BA. A was done first, then B. And so BA would be 3, 0, 0, 1 times by 1, 0, 0, negative 1. First row, first column, 3 times 1 plus 0 times 0 is 3. First row, second column, 3 times 0 plus 0 times negative 1. Second row, first column, 0 times 0 plus 1 times 0 is 0. And second row, second column, 0 times 0 plus 1 times negative 1. And so there's our composition matrix. So in that case, it was not too tricky to get. So if I now want to know what my image is, I now multiply my composition matrix by my point. Points to negative 3. I'll do that down here. Row by column, 3 2s are 6, plus 0 times negative 3 is still 6. 0 2s is 0, negative 1 times negative 3 is plus 3. So the image of that point, better write it in point form so that I get all the marks, otherwise the examiners won't give me all the marks if I don't put it back in point form. All right. Now, Bosser asked a question before, how do you know if it's matrix? This next question is one of those ways that you know, because it's written in a particular way. so this is one of the ways you'll know, because it quite clearly in there tells you you've got a matrix equation, gives you some matrices. And we're asked to find the image of, in this case, an equation. So previous examples I just looked at a point, so now we're going to look at what we might do for an equation. So I'll give you a minute to get that down. Alright, so now I'll put the matrices into this. So this is our transformation equation, matrix equation. So first one, 0, negative 3, 2, 0. Then we've got a bracket. The big X just represents our X and our Y. Plus the B, which is 1 and 2. And that equals our image, X dashed, Y dashed. So with this particular matrix equation, we've got some brackets in here. So those brackets tell us that we need to
Do that first.
correct. Alright, so if the brackets weren't there, you would do the multiplication, but the brackets are, so we do that first. So X we add 1, X plus 1, and Y we add 2, Y plus 2. Alright, so then we've done that, now we do the next one. So 0 times X plus 1 is 0. Negative 3 times Y plus 2. There it is. So that's the row and the column. The next row, 2 times X plus 1 plus 0 times that, so that's just 2 lots of X plus 1. And that is our image. So, we know that negative 3y plus 2 is the image of X. And 2 times X plus 1 is the image of Y. Now what do we have to do with these? Because we're wanting to find the image of Y equals 2X plus 5. So this is our original. And we need to somehow change that for the image. So what do I need to do with these? We need to get expressions for Y and X. So at the moment, here's the line here. So it's going to be difficult for us to remember this mapping. We've got to replace our original Y by something expression. And so here it is here. So we need to get it by itself. And when we get it by itself, we divide by negative 3 and then take 2. And the similar process for the x. We divide by 2 and take 1. So now these are the things that we replace. So that x is going to be replaced by y dash take 1, and the y is going to be replaced by that. So let's have a look. So I'm replacing the y by x dashed on negative 3 take 2 equals 2 lots of x, and I'm replacing x by y dashed over 2 minus 1, and then we've got plus 5 on the end. Alright, you want me to go through all the steps? Yes, you do want me to go through all the steps. Alright,
Nice one.
expand that bracket, then you get y dash minus 2 plus 5. Add 2 to both sides. You get x dashed on negative 3 equals y dashed plus 5.
Can you mark me on time? Thank you.
Alright, and then if I move that 5 over there, I'll get my image is x dashed negative 3 minus 5. So there's our image.
I have preset for you.
Marvellous. All right. Okay, so it's last thing that I need to mention to you. So if you see this, t r squared to r squared and t and you see that are simply indicating transformation. Right, that's all it is. So see, there's the T there, and that's just him saying that there's transformations. So if you like, T with the x, y just says transform x and y. And if you transform x and y, what do you get? You get the image, yeah. So T with that, that's just simply x dash y dashed. So example. So you might see something like this. So you might see something written like that. A transformation t r squared to r squared is defined by t if x, y is that. Alright, so what does it mean? It means do this transformation. Alright, so you'll notice in this one, there's no brackets around here. So in this one we do the times first, then the addition. But as Sarah said, because the previous example had brackets, we do that first. Alright. That's it for today. Anything?